Hello, good morning everyone. My name is Sonali Gahlot and I am the assistant professor in the AKGEC. And now my topic is the scheduling. What is scheduling? First of all, I want to discuss what is the schedule. A schedule is a process of grouping of transactions into one and executing them in a predefined order. Scheduling is the chronological or the sequential order in which the instructions are being executed in a system. A scheduling is required in a database because when some transaction execute in parallel, they may affect the result of the transaction, or maybe some of the transaction may be in conflictions. It means if one transaction is updating the values which other transaction is assessing that values, then the order of these two transactions will change the result of another transaction. So that's why the scheduling is created, so that we execute the transaction without any overlapping. Here I want to discuss what is the scheduling with the help of an example. Suppose this is a schedule, and in the schedule there is a two transaction, that is the T1 and T2. In T1, first of all we read an item. First of all we read an item. Here the value of the A is whatever. Suppose we first of all we take the values of A is 100 and the value of B is 200. Let first we read the value of A, that is the 100. Next we reduce or we get subtract the value of A by 50. That after that A contain the, that is 100 minus 50, that is 50. Now the value of A is 50, that we write the value of A, that is the 50. Now we read the B, and B here is the 200. After we add this value of A to B, that is now B becomes the 150, and we write here write B and commit this transaction T1. In this transaction T2, after the T1 is commit, then we start the T2 transaction and T2 read A, and here A is the 50. Now whatever the value of A is here, we multiply it by the 0.1 and then it enter into these steps. After that we write A and then read B, and then B store the B plus 10. After that write B and commit. In this transaction, in this scheduling, first we I run the transaction T1. After that I will try to execute the T2. This is the in a serial order. But here if we merge these two transactions in this order, then it come like this. That is, first of all let's again we take in any other example, that is the A here is the 1000 and B also is the 1000, and we perform all the steps whatever I have written here, and according this we then get this value of B here and the value of A here. Now after the scheduling, the next point is that what is the serial schedule, and the serial schedule is a schedule in which no transaction start until a running transaction has ended. It means a serial schedule is a schedule in which one transaction is executed completely before starting the another transaction, and transactions are executed one after the other, and this type of scheduling is called the serial schedule, as transactions are executed in a serial manner, and in this way the two transactions can never be intersect to each other, and in this way and according to this serial schedule the result of our transaction is never be conflict. Here is the example of the serial schedule. Here there is a two schedule, that is the this is the first one and this is the second one, and in first one there is a two transactions and like the previous one, and in this scheduling also the two transaction like T1 and T2. In this scheduling, first of all we perform the T1 and after that we perform the T2. Whatever the name here, the serial indicate that until and unless one transaction is committed, after that only we can start another transaction, that is T2. First of all here in this scheduling we first of all we start the T1. After when T1 is committed, then only after we start the transaction T2. This is called the serial scheduling, or we can say that first of all we start the transaction T2. When the transaction T2 being committed, after that only we can start the T1. This is the form of the serial scheduling, and whatever the result we get after these two scheduling are the same. Okay. Now the next topic is that next point is that the non-serial scheduling. What is the non-serial scheduling, or we can say that is the interleaved scheduling. In the scheduling, a schedule that interleave the execution of different transactions. Here, when multiple transactions are executing at the same time, some of the transactions are overlapping, or maybe we can say that the interleaved. It means the second transaction is started before the first one could end, and execution can switch between the transaction back and forth. Like, it can contain many possible orders in which the system can execute the individual operation of the transaction. We will try to understand with the help of an example here. This is the example of the non-serial scheduling. Here there is a two transaction, that is the T1 and the T2. First of all, we start from T1. Here, suppose we take an example, or we say that take the value of A is 100. Then we perform this operation, and whatever we get the answer, we write A. Suppose here we get the value of A is 50. Then after this portion we start to execute this portion of the T2. Here, whatever the value of A is written here, T2 read this value, that is the read A, it means 50. After that, it perform this operation, after this, and whatever we get the value, write A is written here. After performing this part of the transaction T2, we again start the part of transaction T1. Here, whatever we initially take the value of B, that is the 500, suppose. Now we perform this operation, that is the 500 plus 50, and we can write here, that is the 550, and after this we can commit the transaction T1. Then here the value of B is 550 and we commit this transaction. Now the value of B, whatever the value of B, T2 is read the value of B, that is the 550, because T1 first of all write this value and then commit. So then again T2 transaction is start to execute, then the value of B is here 550 rather than the 50. Now after that, it perform this operation and again it write B and then commit. Here in this transaction, in this scheduling, we can change the value of B, that two times, first in the T1 and second one in the T2. This is an example of the non-serial scheduling. It means interleaved scheduling. It means some part of T1 is executing, after that some part of T2 is executing, again T1 is starting and again T2 is starting. Here we can also start this example from the T2. In this non-serial scheduling, we start the transaction from T2. First of all, it reads the value of A, whatever the value of A we initially take, that is the 500. A is here is the 500. Then we perform the operation A minus 50, that is the 450, and then we can write the value of A, whatever we get, that is the 450. Now after this part, execution of this part, we again start the T1, and first of all, the first step is the read A. Read A means that is the 450. Here T1 read the A, that is the 450 rather than the 500. Now it performs this operation, that is 450 multiply, that is 0.1, that is 455, and then A equals to A minus 10, that is whatever we, A is here, that is 450 minus 45, that is 405. Here the right A is 405. Now the value of A is 405 after performing these two operations. Now again after this part of T1, again we start the T2, and first T2 read the B, and whatever the value of B we are taken initially, that is suppose we are taken B is 1000, then it perform this operation B equals to B plus 50, that is 1000 plus 50, and write B. Write B is, that is the and after this we perform the commit operation in T2 transaction. Again after this we start this T1 transaction. Here the T1 transaction read B, and the value of B is here is the 1050, and because T2 perform the commit here. Now again B equals to B plus temp, it perform whatever the value of temp here is the 45, and here we get the P plus, that is the 50 plus 45 like this, and we perform the write operation and then commit. So finally I want to tell you that here these both are the example of the non-serial scheduling. Non-serial scheduling, it means some part of the T1 is executing, and after that some part of T2 is executing, and then T1 and then T2. But it is not mandatory कि first we start from the T1 or the T2. We can start either from the T1 or the T2, but at the last maybe we get the same result, but it is not compulsory कि in all the condition, in all the example we will get the same answer. Now the next topic is the equivalent scheduling. It means if two schedules provide the same result after execution, then they are said to be the equivalent scheduling. It means they may yield the same result for some values or the different result for the another set of values. Suppose we are taking two example of scheduling, that is we can explain this with the help of example further. That's why this equivalence is not generally considered the significant, because it is not the compulsory we always get the same result after the execution of non-serial scheduling. So we cannot generally consider this scheduling. And now we can I want to explain this equivalent scheduling with the help of this example. Here this is the schedule first and this is the schedule 2, and in this in both the scheduling there are two transaction T1 and T2, and here also the T1 and T2. Here first of all T1 is performing and again T2, then T1 and T2, and in this first of all T1 is executing until and is to perform the commit operation, and after that only the T2 is start. Here suppose we take the values of A here, initially A here is 100 and B is 200. Then T1 read the value of A is 100, after that perform this operation and finally it get A is 50. Okay. Then after this part of execution we start T2 transaction, T2 start here and T2 read the value of A. Here T2 read the value of A, that is the 50 rather than the 100, that is A is here is 50. Then it perform this operation, that is 50 multiply 0.1, that is here we get the 5. Okay. Then it perform this operation, A here is the 50, 50 minus 50 minus 5, that is the 45, or write A, it means 45. Now here the value after performing this set of instruction or transactions, we get the value of A here is 45. Then again we start from T1. Here T1 read the value of B, and B here we consider is starting at the 200. B is 200, then it perform this operation, that is 200 plus 50, that is right B, that is the 250, and then perform the commit operation. Here the T1 is committed, it means after that T1 doesn't perform any operation. Now again we start the T2 operation. Here T2 first of all read B, and the value of B here is 250 rather than the 200. Then it perform the B plus temp. Here temp is 5 and write B, that is 255, and then commit. Okay. Then finally we get the value of A is 45. Here after this scheduling, after this performing these two transactions, here the A is 45 and B is 255. This is the result of the scheduling. Now again we will try this another example. Here This is the schedule 2, and it also contains the two transactions, that is the T1 and T2. We start again from A. Let's suppose here the also A is also the 200, A is 100 and B is 200. These are the initially value of A and B. Now start from here, read A. A is 100, then perform this operation, 100 minus 50, then write A, that is the 50. Now it read B is, that is 200, it perform B plus temp, that is B plus temp, that is 200 plus whatever we get the value of temp. Suppose we get the value of temp, that is 5, and that here we can write here, that is 255, and then commit. Here in the scheduling, first of all, firstly T1, we start from T1 and then it also committed first. After the committing T1 transaction, then we will start from the T2, and T2 read A, and here the value of A is, this is that is the 50 rather than the 100. Again we perform the temp operation, that is 50 multiply 0.01 or whatever we get here, that is the 5. The value of temp here is the 5. A is minus temp, that is 50 minus 5. We perform right operation, that is the 45. Here the value of A is 45. Then it again read B, and whatever the value of B is here is 255. Okay, then we plus B 255 plus 50, that is the 305, and then it perform the commit operation. Then we can see that the result of both the scheduling is different. In first scheduling, after completing these two transactions, we get the value of A is 45 and the value of B is 255. But in this next scheduling, that is the schedule 2, after performing these operations, this transaction T1 and T2, we get the value of A is 45, and here is the value of A is 45, but B here is the 305. Okay. The result of both these two transactions are different. Then we can't say that I think there is some mistake here. Oh sorry, here is the value of A is 205, and 205, then 50, then 255. We get the value of B here also the 255. The result of these two transition, or we can say that the result of these two scheduling, that is the schedule 1 and the schedule 2, is same. That's why these are called the equivalent scheduling. It means two schedule are called the equivalent schedule if we can get the same result after performing the operation. Now the next point is what is the serializability. A schedule is serializable if it is equivalent to a serial schedule. Whatever the schedule we have, if we get the result of that schedule equivalent to the serial schedule, then we can say that that given schedule is called the serializability. In serial schedules, only one transaction is allowed to execute at a time, that is no concurrency is allowed. In the previous slides, I discussed the serial schedule. Serial schedule is that only one transaction is committed first, after that the second transaction is start. So in serial schedule there is no concept of the concurrency. But whereas in the serializable schedule, multiple transactions can execute simultaneously, that is in this serializability we can perform the concurrency, or we can say that we can allow the concurrency. There is a two type of the serializability. First one is the conflict serializability, and the second one is the view serializability. Now here, first of all, I want to tell you what is the conflict instructions. Let I1 and Ij be the two transactions, and T1 and Tj are two transactions of the Ti and Tj respectively. So this is the instruction of the Ti and Ij is the instruction of the Tj. Let suppose in T1 transaction the instruction I1 read Q and Ij read Q, then uh, I1, that is the instruction 1 and the instruction J don't conflict, because at the same time two persons or the two instruction can read the same value. When the two transactions or read the same value, same data item, then there is no chances of the conflictions. Then when the two reads operation are performed and even on the same data items, then it doesn't come under the confliction. But like we can also tell with the help of this, in T1 and in Tj, T1 read the read Q and Tj also read the read Q, and in this transaction first Tj read Q and then Ti read Q. In this case there is no chances of the conflictions, because two persons or two transaction can read the same value at a time. But in second case, the instruction I and the instruction J, I perform the read operation on the data item Q and J perform the write operation on the data item 2. These two transactions belong to these two instructions belong to different transaction, but they perform on the different option. One is perform the read operation and another is perform the write operation, but the mean is that the data item is same. We cannot perform the same item, we cannot perform the read and write operation at the same time on the same data item. So here there is a chances of the confliction. So we can say that here the instruction I and instruction J conflict. We can also see here T1 read the Q and after that Tj write the Q. This is a condition of the conflictions, and this is also the same condition. Tj read this and T1 Tj write this and Tj read Q. So here is the chances of confliction, because whenever the Tj write Q, it doesn't perform the commit operation, then there is a chances of the confliction. Now in the third case, again in transaction T1 and in transaction Tj, two different operations are performing, that is the write and read, but on the same data item, then this is also again a condition of the confliction. Now this is the fourth. In the fourth part, these two transactions T1 and T2 again perform the write operation on the same data item. So here is also a chances of the confliction. In short, if I want to tell you, if at least one of the transaction if contain the write operation, then this condition comes under the conflictions. Here there are only three pairs of the confliction, that is the read write, write read, and write write. Here in these three confliction pair, at least one write is here, that's why there is a chances or must be here the conflictions. So now again I want to tell you what is the conflict serializability. If a given schedule can be converted into the serial schedule by swapping is the non-conflicting operations, then it is called a conflict serializable schedule. Or we can say that when we convert the given schedule into a serial schedule, by performing any by swapping any operations or by performing any other methods, then if both the scheduling have the same result, then we can say that this is called the conflict serializable. We can again explain with the help of one example. Here this is a schedule and this is a schedule, and this is contain two transactions, that is the T1 and T2. First of all, we start from the T1 read A and then perform some operations and then write. Again there is, after the T1 perform this part of the execution, again we start from here in T2. T1 read A and then perform this operation, and then T1 then T2. This is an example of the non-serial scheduling. Okay, first of all we try to find out uh, if it contain any confliction or not. In T1 transaction, here is a read A, then we can check this read A with the write A. In another transaction, we can check read A, here is read A, there is no conflictions, but read A, this is write A, there is a conflictions. Okay, this is a one condition. Then write A, then read A, this is the second one. Then again we start from here, that is the read A, we check for it, that is the write A. In another transaction, that is in this, there is no write A here, and then we check for this write A, we check for this write A and read A in another transaction, but here whatever is here is the B item. So again we check in this. So we can find out this schedule is conflict serializability or not. We can also explain with the help of the precedence graph. In a schedule, whatever the number of transaction, it is these are called the nodes of the graph. Here is the T1 and T2. Then first we check the confliction pair. Yes, we get one confliction pair, read A and write A. This is come from T1 and then to the T2. So we can draw a edge from T1 to T2. Then again check for this write A, we get a confliction pair, that is a read A. So again we can draw a edge from T1 to T2. This is the same edge, we are not draw it again. So then we can check for this read A, there is any confliction pair in the T1, there is no confliction. We can again check for write A, there is no confliction here. So again we start for B. For read B, we can check there is any confliction pair, that is write B in T2. This is no, this is a confliction pair. Again we can draw an edge, that is T1 to T2. This is the same edge, T1 and T2. Another then we can check for the write B, there is any confliction pair for write B in the T2 transaction. Yes, this is 1 and this is 2. Again we can we have to draw a edge from T1 T2 to this is again the same edge. In this precedence graph, it contains two nodes, that is T1 and T2, because in this scheduling there are only two transactions, that is the T1 and T2. So in this graph there is no loop, here there is no loop. Then therefore we can say that this scheduling is called the conflict serializable. It means we can change this given schedule into a serial schedule, and then if we convert a given schedule into the serial schedule, then that given schedule is called the conflict serializable. We can convert this schedule, this given schedule, this type of schedule, and this type of schedule is called the serial schedule. Serial schedule means first of all we perform only one transaction without any overlapping. Here first of all we perform the T1 transaction, and after that only we can perform the T2 transaction. This is called the serial scheduling. It means here whatever the given schedule, that is S, we can transform or we can convert this schedule into the serial schedule. Then this given schedule is known as the conflict serializability. Or we can also check with the help of this precedence graph. Here there is no loop in this graph, we can say that this the given schedule is called the conflict serializable. Here this is another example, but here is this is an example of the non-conflict serializable. We can also explain this with the help of the precedence graph. Here the number of nodes is equals to the number of transactions present in a given schedule. Here the number of transaction is 2, then the number of nodes in this graph is 2. First of all, we check the conflict pair for the read A. The conflict pair is the write A in T2. Yes, this is a conflict pair. We can draw an edge from T1 to T2. Then again check for this a confliction pair. Yes, there is a confliction pair for this in T1, that is the read A. We can draw an edge. So if we check here, there is a loop in this graph. If we get a loop in this graph, then this is called the not conflict serializable. So we are unable to swap these transactions in the above schedule to obtain the either the serial schedule T1 T2 or the T2 T1. So that's why this is called the not conflict serializable. Thank you.